Hey everyone, I'm Israel Greatmind Joshua, and welcome to the lab. Today, we're not just going to talk about penetration testing, we're actually going to do one. Seriously, from start to finish, we're going to simulate a complete attack together. You'll see the tools, you'll see the mindset, you'll see how it all works firsthand. All right, let's gear up and dive in.
Okay, so here's our game plan for today. We'll kick things off with the mission itself, getting into the right mindset and understanding the rules of the road. Then, we'll roll right into Phase 1, Reconnaissance, followed by scanning, exploitation, and finally the debrief. We're going to break it all down step by step.
And before we deploy, if you want to be officially on the team for this whole series, go ahead and hit that like and subscribe button. That way, you won't miss our next operation. It really does help keep these labs up and running.
So, what is our mission exactly? We're conducting an ethical hack. Now, what does that mean? It means we're using the exact same techniques a criminal would. But here's the key difference. We have full authorization. Our goal isn't to break things or cause damage. It's to find the weak spots, show how they could be exploited, and then provide the blueprint to get them fixed.
You know, in this world, it all comes down to intent and permission. We're the white hats, the good guys, the professionals who are hired to make things better. On the other end, you've got the black hats. Those are the criminals. And then there's this murky middle ground with the gray hats. They might find a flaw without permission, which, let me tell you, is a very dangerous legal line to walk. For today's mission, our hats are pure white.
And this brings us to the most important tool we'll use today. And it's not a piece of software, it's our mindset. For the rest of this lab, we have to stop thinking like defenders. We're not building walls. We're figuring out how to get over them, under them, or, just smash right through them. To build a really strong defense, you first have to master the art of the attack.
Now, having an offensive mindset like this means you have to operate under a very strict set of rules. This is the bright red line that separates a professional from a criminal. First, and I can't stress this enough, always get permission and get it in writing. Second, you stay within the scope you agreed to no matter what. No damage, no accessing data you're not supposed to. And finally, you report everything. These rules, they are absolutely non-negotiable.
Our entire simulation today will follow this exact 6-phase methodology. It's the professional standard. We've just covered the planning part. Now we're about to jump into reconnaissance, then scanning, exploitation, post-exploitation, and finally reporting. This structure is what keeps our work focused and effective.
And where are we launching this mission from? Our command center for this lab is Kali Linux. The best way to think of it is like a Swiss Army knife for pen testers. It's an operating system that comes preloaded with a whole arsenal of specialized tools we're going to need.
All right, mission is a go. We are now officially in Phase 1, Reconnaissance. This is the intelligence gathering stage. Think of us as digital spies. Our job is to be quiet, to be invisible, and to collect as much public information about our target as we possibly can, before they even have a clue we exist.
So the goal here is to basically map out the target's entire digital footprint. We're on the hunt for things like domain names, IP addresses, maybe what kind of tech they're using, even employee information. We can then use tools like Maltego to take all those scattered bits of data and connect the dots, turning it into a real intelligence map. It's like putting together a giant puzzle.
But reconnaissance isn't just about servers and code. Often, the easiest way into a lockdown network isn't through a firewall, it's through a person. The legendary hacker Kevin Mitnick proved this over and over again. He showed the world that a single, persuasive phone call could be more effective than $1 million security system. That's the power of social engineering.
And here's a perfect example of that in action, a phishing email. You've probably seen tons of these. Let's break down the red flags. First, the subject line creates panic. Urgent. The sender's email looks a little off. And if you hover your mouse over the link, don't click it, just hover, you see it's going somewhere really suspicious. And a generic greeting? Dead giveaway. It's a simple trick, but it's incredibly effective at stealing passwords.
Okay, we've gathered our intel. Now it's time to get a little bit more active. Welcome to Phase 2, Scanning. We're going to take those IP addresses we found, and we're going to start knocking on some digital doors to see which ones are unlocked.
For this, we're using one of the most famous tools in the hacking world, Nmap. Let's break this command down. Nmap is, of course, the tool itself. Now, this -SV flag is absolutely crucial. It tells Nmap, hey, don't just tell me if a port is open. I want you to figure out the exact service and, most importantly, the version of the software running on it. That version number is everything.
And finally, we point it at our target's IP address.
And boom, here are the results. This right here, this is a treasure map for an attacker. We can see 3 open doors, port 22 for SSH, 3306 for a database, but look at this one, port 80 running an Apache web server. And check out that version, 2.4.29. An older version like that, that's exactly what we're looking for. That is our way in.
We've done our recon. We've scanned the perimeter and we've found an open door with a rusty old lock on it. Now, for the fun part. Phase 3, exploitation. It is time to pick that lock.
And this is where AI just completely changes the game. Manually, I'd have to go spend hours, maybe days, researching that specific Apache version, hoping to find a known exploit. An AI-powered tool? It does that same work in seconds. It instantly compares our finding against a massive database of vulnerabilities and can even predict the most likely path an attacker would take. It's a huge force multiplier. So we take that target, our outdated Apache server, and we load up a tool called the Metasploit framework. Think of it as a huge library of pre-made exploits, like a master set of skeleton keys. We just find the right module for our specific vulnerability, point it at the target's IP address, and let it fly. If it works, we get a shell.
We hit enter, and then a command prompt appears on our screen. Success. We're in. We have breached the perimeter. But don't start celebrating just yet, because the mission is far from over. Getting that first foothold is just the beginning. The real question is, what can we do now that we're inside? This kicks off the post-exploitation phase. Right now, we're just on a public web server. It's not that interesting. The real goal is what we call lateral movement. We use this first compromised machine like a beachhead, a launchpad to pivot deeper into the internal network. Remember that database server we found earlier? That's our next target. This is how a small breach turns into a catastrophic one.
So, after we've moved through the network, documented everything we can access, the attack part of the simulation is over. But for an ethical hacker, the most critical work is actually just beginning. It's time for the debrief. It's time to write the report.
This is our final product. This report is our most powerful tool. We don't just say, hey, we got in. We carefully detail every single vulnerability. We assign it a risk level, like critical for that Apache server. And we provide a clear step-by-step recommendation on how to fix it. This is how we provide real value. This is how we help make organizations safer.
Now, if this whole process got you excited and you're thinking this might be a path for you, here's my advice. 1. Stay curious. Never ever stop learning. 2. Practice, but only in safe, legal environments like this one. Build your fundamentals, document everything you do, and remember, in this field, your ethics and your reputation are everything.
And that concludes our attack simulation. But our series is not over. Your next mission, should you choose to accept it, is going to flip the script completely. We're going to dive into incident response. What happens when the bad guys are the ones who get in?
Think about it. We just spent this entire lab learning how to break in. But what happens when a real attacker gets through? When the alarms are going off and the clock is ticking? Are you ready to manage that crisis, contain the breach, and lead the recovery? We're going to cover all of that next time. Thank you for joining me in the lab.